Next, we are going to see the graphs. Okay, graphs. First one, we have seen what? Intensity versus current graph. This shape, you can see the graphs, you can study. Next one is what? Different intensities, photo current versus voltage. Here only major topic. Listen here. Here you can see the negative potential. Whatever we are giving, this negative retarding, this potential is what? Negative collector plate potential, and you can see very well when the positive part is there. When it is positive, the current is what? Increasing. Okay. This is the voltage you are giving to what? Okay, listen. The voltage you are supplying V. Hello. This is the collector plate potential you are giving. When it is positive, according to the intensity, you can see the current is increasing. Finally, it will be a constant. This is current is called saturation current. Are you able to understand? Actually, current will be increasing when the potential is positive and more. Current will be increasing, but it will not increase much. So what will happen means current will be going and it will be a constant, that is called saturation current. And what you can observe here means some detailing is here. Hey, some detailing is there. I1, I2, I3 were intensity increasing. When the current intensity is increasing, what happened to the photo current? It is also increasing. Saturation current also increasing when intensity is increasing. Hope it is clear. Now, remaining this side you see. This side, negative potential you are increasing. That means collector plate you are applying. Collector plate you are applying more and more negative means it will start decreasing, comes to 0. Clear? You understood? So there was a question in the question paper, when different intensities are there, what you can say about the kinetic energies? From this graph, what you can understand about kinetic energy? That's the exam point here. Now listen here. You know very well, kinetic energy, we wrote what? QV0 or EV0. Am I correct? So kinetic energy, kinetic energy is what? Directly proportional to the stopping potential. That is the meaning. Now you listen. For intensity, whenever intensity is different, stopping potential is what? Same. What does it mean? Kinetic energy is independent of intensity. This point directly you cannot understand, but you can infer from the graph. Very important point. Kinetic energy is what? Directly proportional to the stopping potential. And one more thing, for different intensity of light, nothing will happen. Kinetic energy is actually independent of what? Intensity. I hope it is clear. Already we have written intensity equation directly proportional to number of photons only. Okay, intensity directly depends on what? Number of photons. These points and all only from exam twisted question will come. So இங்க என்ன பண்ண? What we got? Kinetic energy which is directly proportional to stopping potential. Single stopping potential only we have. That means intensity change ஆகும்போது stopping potential என்ன ஆகாது? Change ஆகாது. It will be a constant. What does it mean? Kinetic energy is independent of intensity. If you have book, you write somewhere. Kinetic energy independent of intensity of radiation. Kinetic energy is independent of intensity of radiation. This is one of the reasons why we rejected wave theory. very important topic. Wave theory வந்து reject பண்ணதுக்கு ஒரு reason வந்து இதுதான். Okay. According to wave theory, kinetic energy depending on what? Intensity. But according to experimental observation of photoelectric effect, kinetic energy is what? Independent of intensity. I hope this is clear to you. Is this clear to you? Same. That's what from the graph we got. Different intensity க்கு கூட stopping potential same தான் கிடைச்சே. அதுக்கு மீனிங் என்னது? Kinetic energy is independent of intensity. This is the one of the reason why we rejected wave theory and we accepted photon picture, photon theory. இதெல்லாம் last வரும், consolidation வரும். Okay. Now what is the next graph? Can you see the next graph? What is the next graph? What you can see here? Three different, actually it is new, not V. It is new actually. Nu 3 greater than nu 2 greater than nu 1. இந்த மாதிரி மூணு frequency. அதாவது light ஓட frequency is different. If three frequencies are given, this is also another reason why we rejected wave theory. Three frequencies are given. What are they? Nu 1, nu 2 and nu 3. Look at the graph and what you understood, you tell me. In our material, I have given V01. That only this. V01, this is what? V02, this is what? V03. Different stopping potentials. Different frequency means we have what? Different stopping potential. Is it clear? How many stopping potential we are getting? Three different stopping potential, V01, V02 and V03. When the frequencies are different, you didn't hear a dog barking. Why you are laughing? Huh? Three different stopping potential we are getting for three different frequencies. What you can understand from this? When frequency of light changes, you can see one more thing. For them, saturation current is what? Same. Hope you understood. இது வச்சு கிராஃபுக்கு கொஸ்டின் இருக்கு, அதனால சொல்றேன். Problems are there. இது மூணு different frequency, same material. For example, sodium, potassium ஏதாவது ஒரு மெட்டீரியல் எடுத்து you change the frequencies, nothing will happen, same saturation current will get. Keep this point in mind, we need this for question. Saturation current is same for different frequency, but what is changing? What is changing? When frequency changing, what is changing? What is changed here? Tell me. Stopping potential or retarding potential or cutoff potential is changing. Which is having more cutoff potential? More frequency. Okay. Whether this graph is correct? No, this is wrong. I think. This is nu 1, this is nu 2, this is nu 3 now. If nu 3 is greater, like that only, this material it is colored. You see this material? What is it? F1 and F2. You can see F2 greater than F1. What is the graph? When F2 greater than F1, nu 02 is greater than nu 01. See this one. That's wrong. Nu 02 is greater than nu 01. Hope it is clear. Is it clear? When frequency is more, what is happened to stopping potential? Stopping potential also is more. This is the inference. More frequency, more stopping potential. இங்க வந்து ரெண்டு frequencies தான் plot பண்ணிருக்கு. மூணு frequency na you can put like this. Okay? Clear? அப்ப இங்க என்ன inference சொல்லு? According to photoelectric effect experiment, saturation current will be same for three different frequency for the same material. Same material. And one more thing, frequency is changing when stopping potential also changing. That means kinetic energy is changing according to the frequency, isn't it? But according to wave theory, it's not like that. It should not change. When frequency is changing, stopping potential should be same according to the what wave theory. This is one other reason why we rejected what wave theory and we accepted what photon picture. இது வந்து இந்த experiment observation கூட ஒரு reason which is not like this according to wave theory. அப்ப இது கூட another reason. One more reason இருக்கு wave theory reject பண்ணதுக்கு. Actually the which one? our photoelectric experiment is spontaneous. Spontaneous means what? Or instantaneous. You can say instantaneous. Instantaneous. In the point patti na sollirukku munnadi. Okay. Instantaneous means what? As soon as the light strike on the material, electrons will emit. This is called instantaneous process. But according to wave theory, it is not instantaneous. അപ്പോൾ ഇതെല്ലാം വന്ന് പോസ്റ്റ്ലേസ് മാതിരി. Okay. So which all graphs we see? One more graph is there. Listen. Listen here. This is another graph. In the graph, how you are getting, I will explain now. How to get this graph. This is another very important graph for Einstein's photoelectric effect equation. So let us discuss this graph. I hope other graphs are clear. Any one graph, sure question for your exam. இப்போ நான் ஓரோ கிராஃபிலும் வந்து மைன்யூட்டா கொஞ்சம் பாயிண்ட் சொல்லி இருக்குல்ல, that also very important. Hope it is clear, these things. Now I will tell you how to get the other graph. Last graph I showed you, no? That graph only. That only I have to explain. What is our Einstein's photoelectric effect equation? Next is what? Einstein's photoelectric effect equation. You tell me what is the equation? Another Einstein's another. Einstein's photon picture or Einstein's photoelectric equation. Einstein's photoelectric equation. What is the equation? What he told? So a material surface is there. Whatever radiations are coming now. According to Einstein, the radiation which is coming now, listen to me properly. Lot of questions, assertion, reason, MCQ, everything can come from this set. Okay. Now, what we have means, according to Einstein's picture, energy is not like what? A continuous radiation. Instead, it is like a packets. ഓരോ പാക്കറ്റ് ഓഫ് എനർജിക്കോ എന്നത് h nu. In the packets യുടെ പേര് എന്നത്? This quantum of energy is called what? Photons. இதுதான் ஐன்ஸ்டீன் சொன்ன photon picture. Actually rejected which theory? Which theory we rejected? Wave theory complete ரிஜெக்ட் பண்ணி தான் ஐன்ஸ்டீன் வந்து என்னது இந்த photon picture பற்றி சொன்னது. இனி எதுக்காக அதை ரிஜெக்ட் பண்ணது? According to experiment 1195 page, all the postulates given. All of you should study how many points given? 4 points given. அதுக்கு முன்னாடி you can see laws of photoelectric emission, that also you should study. Laws. It's that I will give. Laws of photoelectric. Who written this one? From where you got it? For them I taught. This one I will give. Okay, you write there. Laws of photoelectric emission. This space is blank. You should write. நாளைக்கு எக்ஸாமுக்கு இது வந்தேனா you should write. First point you write. Laws of photoelectric emission. Write down. Revision note ல கூட எழுதலாம். No problem. What are the laws? First point. For a given material. For a given material. Laws of photoelectric emission. Write down. For a given material, there exists a minimum frequency. For a given material, for a given material, there exists minimum frequency of radiation. For a given material, there exists minimum frequency of radiation. There exists minimum frequency of radiation. There exists minimum frequency of radiation below which there exists minimum frequency of radiation below which no emission taking place. Below which no emission taking place. Below which no emission taking place is called threshold frequency. Is called threshold frequency. No emission taking place is called threshold frequency. What is the symbol for threshold frequency? Nu 0 or f0. Put this in bracket. Nu 0 or f0. Ini laws என்னது கேட்டா you should write these points. இது அப்படியே படிக்கணும். Next point. For a given metal and frequency, 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 the photoelectric current is directly proportional to intensity of radiation. Intensity of radiation. Intensity of radiation. Next point, above threshold frequency. Next point, above threshold frequency. Above threshold frequency, the maximum kinetic energy of emitted photoelectrons, the maximum kinetic energy of emitted photoelectrons, is independent of intensity of radiation, independent of intensity of radiation, but depends on frequency of radiation. Last point, the photoelectric emission is an instantaneous process. Emission is an instantaneous process. Instantaneous process means, what is it? 10 to the power, what is instantaneous means? 10 to the power minus 9 seconds. This you put in bracket, any MCQ comes you can use. Instantaneous process, 10 to the power minus 9 seconds. That means what? Within 10 to the power minus 9 itself, it starts emitting electrons. So, these are the things. Now, let us go through the most important thing in the entire book, entire chapter. Okay, what is the thing? Why we are rejecting? Here, many students used to skip. They couldn't understand what is the consolidated form. But you should not skip. It is actually easy. Just remember these 4 points. It will be very easy for you. What is the first point? According to wave theory, when the intensity is increasing, radiation intensity increase பண்ணும்போது kinetic energy also it should increase. Okay, but according to experiment, kinetic energy of photoelectron is independent. You remember which graph? எல்லா இன்டென்சிட்டிக்கும் ஒரே V0 அந்த கிராஃபில். You remember? Same V0 for I1, I2 and I3. You remember? What does it mean? Kinetic energy is what? Independent of intensity of radiation according to experimental observation of photoelectric effect. But really, what is it? According to wave theory, it is dependent. Appo wave theory reject aidicha? Reject aidichu. One point. Okay, according to wave theory, it is dependent. Here it is what? Independent. That is the sentence. And the italica எழுதிரது மட்டும் underline பண்ணு. It fails to explain, experimentally observe the fact that velocity or kinetic energy of emitted photoelectrons is independent of the intensity of radiation. Actually, அது depend தான் wave theory. இது இங்க வந்து independent இருக்கு. புரியுதா? அதுதான் அங்க பாயிண்ட். அது அப்படியே படி. Second one. According to wave theory, intensity of radiation is independent of frequency, but here it is dependent. Correct? Why? Kinetic energy is depending on stopping potential. Different frequency ki different stopping potential da graph li vandadu. Adukku meaning enadhu? When frequency is changing, what is changing? Kinetic energy is changing da artham. But wave theory la adu change aga koodadu. Romba minute ana point adu. Okay, according to wave theory, kinetic energy depending on what? Kinetic energy depending on frequency. But inga vande adu kinetic energy வந்து என்னது independent இருக்கணும். ஆனா இங்க வந்து என்னது dependent தான். Different frequency க்கு we are getting what? Different kinetic energy. What does it mean? Again wave theory rejected. You think like this, whatever we have experimentally na அதனாலதான் ரிஜெக்ட் ஆயிருக்கு. அந்த மாதிரி ஞாபகம் வச்சா ஈஸியா இருக்கும். நெக்ஸ்ட் பாயிண்ட் என்னது? threshold frequency. Okay, according to wave theory, ஏது frequency of radiation போட்டாலும் electrons வந்து emit ஆயிடும். But இங்க அந்த மாதிரி இல்ல. Tell me what is the reason? What we are getting here? Here, only for a particular frequency above which emission happen. And the frequency ட பேர் என்னது? Threshold frequency. இனி ஒன்னு கூட இருக்கு, threshold wavelength. How will you relate threshold frequency and wavelength? Nu 0 is equal to C by lambda 0. Note this point. Nu 0 threshold frequency na. How to get threshold wavelength? This is threshold wavelength. Any, what is C? 3 into 10 to the power 8 meter per second. That's it. Note down. Because they asked how to get lambda 0 means, don't think it is something else. You can easily get, they are inversely proportional. Remember, nu 0 and lambda 0 is what? Inversely proportional. Because they are related by nu is equal to C by lambda relation. What is lambda 0? Threshold wavelength. Badrinath, you have written this. Show me where you have written. இப்போ நான் எக்ஸ்ட்ரா சொல்லுறது மொத்தமே எக்ஸாம் பாயிண்ட் ஆஃப் வியூ. இதொன்னும் வேண்டனா, நோ நீட் டு சிட். So what is it? Nu 0 is equal to C by lambda 0. Lambda 0 is what? Threshold wavelength. Nu 0 is what? Threshold frequency. Hope this is clear. So that's about last point, last but not the least. What is it? It is spontaneous. 10 to the power minus second kulla, minus 9 second kulla, the electrons are rejected, emitted. What about wave theory? Wave theory actually ஒரு எலக்ட்ரான்ஸ்க்கு வந்து ஒரு டைம் கேப் இருக்கும், அதுக்கப்புறம் தான் எலக்ட்ரான்ஸ் வந்து எமிட் பண்ணும். ஆனா இங்க இல்ல. இந்த 4 பாயிண்ட்ஸ் நல்ல ப்ராப்பரா படிச்சா you can answer many questions. So you understood up to this. Now Einstein's photoelectric effect equation is pending. Up to that, is it clear? So what all things we studied now, just now? First one, what are the types of emissions? What is the definition of electron volt? Then we studied what? Photoelectric effect experiment. All the graphs is there. Extra graph also I have given. You have seen that extra graph also one time you go through. Then what is it? Next, why we have rejected which theory? Wave theory. Idu varekum you have to read now.